Today we are going to discuss about rational numbers, chapter number 1, standard 8, mathematics. First of all has to do warm-up exercise. Healthy body, healthy mind. Before starting anything, pray and do little physical exercise. Let's begin. Introduction to rational numbers. We all are knowing the types of numbers in lower classes. We were knowing about natural number, whole number, integers, etc. So I want to revise a natural number. Natural number is also known as counting numbers. Counting numbers means it starts from 1, 2, 3, 4, 5, etc. It's a countless number. That means we can say infinite numbers. Next one is a whole number. Whole number is nothing but including natural number and 0. So here the smallest whole number is 0. It's begin with 0. Then after 1, 2, 3, After that you may be knowing about integers. This 0 and 1, 2, 3. These are called the positive number. But sometimes you may have to come into the minus also, like as a minus 3 degrees centigrade temperature, minus 28 degree centigrade as temperature. Okay, so these numbers are included in integer group. Integer will start from minus number. Suppose we can take ... minus 4, minus 3, minus 2, minus 1, and then after whole numbers, that's 0, 1, 2, 3, 4, 5, etc. So this I am trying to put in the form of a circle. This is the natural number. Natural number comes into the whole number, and these all numbers are included in integers. So up to here you had no doubt. Now our first chapter of standard 8 is a rational number. Student, did you know about fraction? Yes, fraction. Yes, beta. Look at that, fraction and rational. Look at the same meaning, like that way you can understand. Yes, little bit it is okay. Rational and fractional both are same. But there is a one definition is there for rational number. It is comes in the form of P upon Q, or you can say A upon B, where Q and B never become a 0. These forms represent the rational numbers. There are negative rational numbers are also there, isn't it? So last circle is showing all type of number including positive, negative, 0, and in the form of fractions, that is P upon Q. I hope you got the clear idea regarding numbers. Let's give the definition of rational number. A rational number in mathematics can be defined as any number which can be represented in the form of P upon Q, where Q, that means the denominator, is greater than 1 or greater than 0. We can say it's greater than 0. Also, we can say that any fraction fit under the category of rational numbers where denominator and numerator are integers. Be careful. Integer means negative number, positive number, and 0, and the denominator is not become a 0. That means we can say in mathematical form q is not equal to 0. This is the sign of not equal to. Yes, good. Let's see some more thing regarding properties of rational numbers. The result of two rational number is always a rational number. Is we multiply, add or subtract them. A rational number remains the same is we divide or multiply both numerator and denominator with the same number. Like as we can say equivalent fraction. The value of the both things remain the same. Sum of 0 and a rational number revert the same number itself. Yes, for that I want to give one example. 3 plus 0. Answer is 3. Okay, once again, rational numbers we can define in easy way. The numbers of the form p upon q, where p and q are integers and q is not equal to 0, are known as rational numbers. The collection of numbers of the form p upon q, where q is greater than 0, is denoted by q. That's a natural number, and then after whole number w, z as a rational numbers are known as q. Rational numbers include natural numbers, whole numbers, integers, and negative, positive fractions also. Good. Let's see. A rational number can be illustrated as a ratio. This means that a rational number can be written as a upon b. For any two integers a and b, the notation a upon b is also called a fraction. For example, 3 upon 4, 5 upon 7, 4 upon 9, etc. All are fractions. It is a rational numbers. Rational numbers can represent on number line also. Here is an example of number line showing 0, 1, 2, 3, minus 1, minus 2, minus 3. But in between 0 and 1, there are two numbers are written, 1 upon 4 and 1 upon 2. So these both are the rational numbers. Same way, on the left side, minus 1 and minus 2, there is one number written, minus 3 upon 2. This is also a rational number. To express rational numbers appropriately on the number line, divide each unit length into as many number of equal parts as the denominator of the rational numbers, and then mark the given number on the number line. Little more about a reciprocal. Students, see here I am writing one number a upon b. Suppose I am writing 3 upon 4. Okay, what is the reciprocal of 3 upon 4? Very easy. You have to make it a numerator as denominator and denominator as a numerator. And one common formula, one common property for this one, a number and reciprocals multiply gives 1. So suppose we multiply the reciprocal of 3 upon 4 is 4 upon 3. So whenever we can multiply a reciprocal with a number, we will get answer 1. How? Very easily. We are knowing a multiplied sign numbers of numerator and denominator can cut. See, like this way. 4 ones are 4. This 4 ones are 4. 3 ones are 3. 3 ones are 3. Now see the numerator. 1 into 1, that's a 1. Denominator also 1 into 1, that is 1. So answer is 1 upon 1, that's a 1. So that's why here reciprocal A upon B is equal to B upon A. When these both numbers are multiplied, it gives the answer 1. Got the idea? Yes. And one more thing. As you know very well, 0 is called the identity for the addition of rational numbers. It is the additive identity for integers and whole numbers as well. 1 is the multiplicative identity for rational number. Inverse property. Have you heard the word inverse anytime? Yes, there are two types of inverse. Additive inverse and multiplicative inverse. Additive inverse is a number which is added with the same number but the sign is different. Suppose number is positive, so you have to add same number negative. Suppose I will take an example to clarify this idea. I am taking 3. Now you have to put the plus sign but add one number, same number, and get the result. It is a 0. How will get the 0? By putting minus sign here. So 3 plus minus 3 gives the 0. The sum of any number and its additive inverse is 0. A is the additive inverse of the number A. So minus A, look at here. Minus A is the additive inverse of the number A. When these both numbers are added, it gives the answer 0. Good. Now regarding the multiplicative inverse, the product of any number and its multiplicative inverse is 1. Suppose there is a number A. So what is the multiplicative inverse of A? Simple, 1 upon A. That gives the answer 1. See, here is the answer. A into 1 upon A is equal to 1. Remember the things? A number is multiplied with a reciprocal of that number. Suppose here number 9 is there. 9 multiplied by 1 upon 9 gives the answer 1. But here only first number 9 is not there. There is a 1 is there. So 9 upon 1. So what is the reciprocal of 9 upon 1? 1 upon 9. So that's why this 9 cut. 9 ones are 9, 9 ones are 9. And 1 into 1, that's a 1 upon 1. Gives the answer 1 only. Clear? Good. These all properties, all the informations are very useful to solve our exercises. That's why the whole chapter introductions we can try to cover in our session. Properties of rational numbers. There are closure properties. First of all, we can discuss regarding closure property. Rational numbers are closed under addition. That is, for any two rational numbers, a number A and B, that means A plus B, also a rational number. For example, 8 plus 3, these two numbers are added. Answer gives the 11. And 11 is an integer, but integer is also known as a rational number. That's why it's a rational number. Clear? Next, rational numbers are closed under subtraction. That's why 25 minus 11. So it will give the answer 14. 14 is also a rational number. So don't be confused, student. 14 is an integer, but integer is lying under the rational number. Rational number closed under multiplication also. Whenever you multiply two numbers, you will get a rational number. Suppose here 4 into 2. This is our rational numbers. Rational numbers are closed under division also. Yes, that is for any rational number, a upon 0 is not defined. That's why we can say rational numbers are not closed under division. So be careful regarding this one. Rational number are not closed under the division. Okay? Yes, very good. See, in your textbook, all the properties are given regarding rational number, whole number and integer, which is very useful to get the answers very easily. Suppose here commutative property under the rational number possible, then examples are also written, associative properties, identities, inverse property and distributive property. Okay, addition, just we can got the answer here, a plus b is equal to b plus a. Whenever we can commutative 2 plus 3 is equal to 3 plus 2, both are giving the answer 5. Same way for this property, you can multiply two numbers in any order. 2 into 3, 6. You can take 3 into 2, answer is 6. Isn't it better? Clear? Very nice. Associative property is nothing but groupism. Suppose there are three numbers. In these three numbers, a plus in group b plus c, in bracket b plus c. We can write these three numbers as this way, a plus b in group and then plus c. The answer remains the same. Answer remains the same. Same way, we can just check it, b, a into b into c. So this is also properties satisfied. Identity for addition is 0. Whenever you add 0 to any number, answer remains the same number. So identity for multiplication is 1. If you want a same number, which number you have to multiply? 1. Suppose there is a 9. How to get 9? Very simple. 9 into 1 gives 9. Good. Inverse property. Just now we discussed in previous slide, a plus minus a gives the 0. And for multiplication, a into 1 upon a, that means a reciprocal, gives a 1. So be careful. In addition, answer is 0, and in multiplication, answer is 1. Good. Now, we can find out rational number between two rational numbers. So there are so many types of things you can get it. How to check these things? Very simple way. Suppose, can you find more rational number between 2 upon 5 and 3 upon 5? Yes, we can write 2 upon 5 as 2 upon 50. Why? Because I multiply 10 with 2 and multiply 10 with 5. The value remains the same. Same way, 3 upon 5 can also write 30 upon 50. Why? Because I want to make both the numbers in between some numbers I want to find. As per our knowledge, 2 and 3, there are no numbers are lying. But student, there are number of points are lying. See, 2 upon 5 is written here like this way. Isn't it? And 3 upon 5 is here. In place of 2 upon 5, I can write 20 upon 50. Same way, in the place of 3 upon 5, I can write 30 upon 50. So after that point, I can make it a 10 parts. 21, 22, 23, 24 and everywhere the denominator remains the same 50. So you can find so many numbers between two rational numbers. Countless. We can say it's a countless. For your information, I took example of 10 numbers. Now, how to add two rational numbers and subtract two rational numbers? First, I want to take an example of subtraction. The question is here. You can see 3 upon 4 minus 19 upon 10. Yes, two rational number subtraction. Always check the denominator first. In first number 4 is the denominator, in second number 10 is the denominator. It is not possible to do these things. So for that, make the denominator equal. LCM of 4 and 10 is a 40. So we can make it a LCM of denominator. It's a simple way to get the answer. This 30, how it comes like this of first number. 3 upon 4 is the number. We can multiply numerator and denominator by 10. 3 tens are 30. 4 into 10, 40. Same way, 19 upon 10, we can multiply 4 and divide by 4. The value remains the same. I will get 76 upon 40. Now I am having the other two numbers, 30 upon 40 minus 76 upon 40. Very simple. Now denominator is common. We can write one time, 40 is a down, and whatever the numerator, we can subtract 30 minus 76. As we know, the student of standard 8, both numbers are different signs. We can subtract. 76 minus 30, that's a 46. And sign of the bigger number becomes in answer. So that's why answer is minus 46 upon 40. My final answer is here 46 upon 40. Now check it for addition. You may be disturbed of the how to do the addition. 1 upon 5 plus 2 upon 5. Now move right side 1 unit. On number line also we can represent these things. And how to get the answer? It is plus minus given here. See, 1 plus 5, 1 upon 5 plus 2 upon 5. Here the both denominator are equal. So we can write 1 time, and numerator has 2 plus. 1 plus 2 gives the 3. So answer 3 upon 5. On number line we can represent very easily. First of all, we have to write 0 and then after 1. In between there are 5 cuts. So 5 parts I want to make. So 1, 2, 3, 4 and 5. So first part is showing 1 upon 5, second is 2 upon 5, 3 upon 5, 4 upon 5. First of all, what is there? 1 upon 5. I want to move to 1 upon 5. So I am here now, and then after how much I want to add? 2 upon 5. That means 2 steps I want to move. But which direction? Addition is that. That's where I said 1 step and 2 step. Where I reached here? 3 upon 5. That's my answer. Clear? Good. Multiplying rational numbers or fractions we can very easily. Whenever you multiply two rational numbers, we have to multiply numerator with numerator, denominator with denominator, and plus into minus. Plus into minus, that means give the minus. Plus into minus gives the minus, and minus into minus gives the plus. This rule you are knowing very well. So here one number is negative and one number is positive. The answer remains the minus. So answer is 5 2s are 10 and 6 3s are 18. Reduce the form. This 10 we can write 2 into 5. And this 18 we can write 2 into 9. This 2 cut. What is the left further? Minus 5 upon 9. Not multiplying or reduced form. you can do directly. Here is the number. Our number is this one. Minus 5 upon 6 multiplied by 2 upon 3. Student, don't afraid. This dot is showing the multiplication sign. This dark dot is showing the multiplication sign. Okay. So here 2 ones are 2. 2 3s are 6. So now 5 ones are 5 and 3 into 3. 3 3s are 9. This answer and this answer remain the same. Good. Now let's see. Divide the number 7 upon 15 divided by 3 upon 4. As we know, we can multiply the second number with reciprocal. 3 upon 4 reciprocal is 4 upon 3. So here I written with the red color. This is the reciprocal of 3 upon 4. Now, as we are knowing multiplication of rational numbers, numerator with numerator, denominator with denominator. And last one, 7 4s are 28 and 15 3s are 45. Very good, student. We can say this number is a fraction and rational number or not. So examples are here. All the decimals numbers are represented with the rational numbers. And root 3, students, this is the root 3. It's not a rational number. It's an irrational number. The fraction is not possible. Okay, just for your information. Good. Here are the what we have discussed given in your textbook. 9 points are given, which already we discussed in these slides. Thank you. Have a good day.